our root 3 root 27 everything raised to power 1 times 4 root 16 everything raised to power 1 is equal to what? 3 root 27 is 3, 4 root 16 is 2. So our final answer is 6. Example number 20. Given that 3 times 9 raised to power 1 plus x is equal to 27 raised to power minus x, find x. This our 3 is just like, can be rewritten, we'll just rewrite what we're having here. 3 raised to power 1. We'll take this to 3 also, and then change this one also to 3 raised to power something. This will be 3 raised to power 2. Our 9 is 3 raised to power 2. 1 plus x is equal to 3 raised to power 3 the bracket minus x. So what we're having is 3 raised to power 1 times 3 raised to power 2x plus and 2. 2 times 1 is 2. 2 times x is 2x is equals to 3 raised to power minus 3x. 3 times minus x is minus 3x. So what we just have is 3 raised to power 1, once we are multiplying we had, plus what we have in here, that will be plus 2 plus 2x is equals to 3 raised to power minus 3x, which is equals to 3 raised to power 3 plus 2x is equals to 3 raised to power minus 3x. Now, what we are going to do is, we are going to, since these our numbers are the same, so we neglect them and then take their powers. So what we are having is 3 plus 2x is equals to minus 3x. If we should take this to this side, it will become minus. So we'll be having 3 is equals to what? Minus 3x minus what? This will be minus 2x. So we'll be having 3 is equals to minus 5x. So what we're having here, we'll divide both sides. We're going to divide both sides by minus 5. That will be 3 divided by minus 5 is equals to minus 5x all over minus 5. This minus will cancel this minus, this 5 will cancel this 5, and then we can easily say that our x is equals to minus 3 all over 5. With that, we come to the end of indices. Our next topic is logarithm, as you can see on the board. The logarithm of the number q to a given base x is the index to which the base must be raised in order to get the given number. Thus, if q is equal to x raised to power y, this implies that log base x, log q base x is equal to y. That is, when we have something like q is equal to x raised to power y, that will be log base x, log q base x is equal to y. If you are being given a question in this format, you can easily say that q is equal to x raised to power y, or log q base x is equal to y. Some questions usually play around this, what we're having here, usually play around this. That is, examiners usually play around this in testing students. Q is equal to x raised to power y. Q is equal to x raised to power y is known as the index form, while log q base x equals y is known as the logarithm form. For example, the logarithm to the base 10 to the base 10 of 1000 is 3. That is log 1000 base 10 is equals to 3. If you are to look at this from what we are having here, we can just say that 1000 is equals to this our base. We come up and this answer will be our power. If you should check this, 10 times 10 times 10, the same thing as 10 raised to 3. 10 times 10 will give us 100. 100 times 10 will give us 1000. In general, if y is equal to n raised to power x, then x is equal to log y base n. Laws of logarithm. The first law, for the product of two numbers x and y, add their logarithm. That is, log xy is equal to log x plus log y. Second law, for the division of x by y, subtract their logarithm. That's when we have log x over y, it's the same thing as, that is equal to log x minus log y. The third law, log x raised to power a all over n, which is equal to a all over n log x. That is, when we have log x raised to power a all over n, the same thing as a all over n log x. Number 4 is log 10, log 1 base 10 is 0. I said log 10, log 1 base 10 is equal to 0. From the explanation of that I explained the other time, this one will be equals to the base raised to power the answer. We've seen things like this before. Law number 5. That's log 10 base 10, which is equal to 1. That is 10 raised to power 1 is equal to 10. The sixth one, which is the last one we'll be considering for now, is log 1 over b raised to power a, which is equal to log b raised to power minus a, which is equal to minus a log b. Then we now go to common logarithm. Just as we can see on the board, logarithm defined to base 10 are called common logarithm. The logarithm of a number consists of two parts, namely the characteristics and the mantissa. The characteristics is the integral part, while mantissa is the decimal part. For example, the logarithm of 30 is 1 point, that is a decimal point, 4771. It is being grouped into 3 different aspects. The 1 serves as an integer, which is the characteristic, then the decimal point, then the decimal fraction, which is also known as mantissa. We'll now take a look at some examples. Example number 1. If log a is 10 is equal to 4, what is a? What they are just asking us is just to get the index form of the logarithm. So what we are going to do here is just that for us to get the index form, just write a is equal to what? 10, that is our base, raised to power 4, which is the same thing as a is equal to 10,000. Final answer. Example number 2. Evaluate without using mathematical tables or slide rule. Log 25 base 10 plus log 32 base 10 minus log 8 base 10. Here we are going to make use of law 1 and 2, where addition is the same thing as multiplication and then subtraction is the same thing as division. So what we'll be having here will be log into brackets log 10, we have the same base, log base 10, 25 times 32 all divided by 8. So So what we are having here is 32 divided by 8 is 4. So what we are having here is log 100. 25 times 4 is 100, is 10, which is also equals to log 10 square base 10, which is equals to 2, can you see? 2 log 10 base 10. Applying the fifth law, log 10 base 10 is 1. That is our fifth law, log 10 base 10 is 1, so we'll be having 2 times 1. That is if you applying log number 5, the fifth law. So we will be having something like this, which is equals to 2, which is our final answer. Example number 3. If log 2x plus 1 into brackets base 10 minus log 3x minus 2 into bracket base 10 is equals to 1, find x. Here we'll first apply law number 2, which simply implies that our subtraction is the same thing as division. Is equal